Now we're going to take a look at cycloalkanes. So far we've only focused on linear straight chain alkanes, but at the very beginning of the chapter I had mentioned cycloalkanes, which are not isomers of alkanes because they have a different um, molecular formula, right? Remember CnH2n. And so all cycloalkanes certainly contain a ring. The simplest cycloalkane that you can have is cyclopropane. So we're talking 3 carbons. Obviously, there is no cyclomethane or cycloethane because you can't form a ring with only 2 atoms. So cyclopropane becomes the smallest, simplest cycloalkane that you can actually have. And then a 4 carbon ring looks like this, looks like a square. It's cyclobutane. Then we have a 5-membered ring that is cyclopentane, right? And we draw it like that. And then we have a 6-membered ring that is cyclohexane. And these 4 are relatively easy to draw. Then it becomes a little bit more complicated to draw. This is what the shape of cycloheptane looks like. And then we have an octagon, which is cyclooctane, right? So these are common rings that we're going to encounter throughout our studies. Now, when we think about substituted cycloalkanes, if there's only one substituent, monosubstituted cycloalkane, then we've looked at naming alkanes and we said that each substituent needs a number. When we're dealing with cycloalkanes, when there's only one substituent on the ring, it could essentially be on any of the carbons. So there are no numbers that are required for naming monosubstituted cycloalkanes. For an example, here I have a methyl substituent that is on a cyclohexane ring, and so this is simply methyl cyclohexane. Another example is if I have 1 bromine on a cyclopentane ring, this becomes bromocyclopentane. Now, when I have multiple substituents, then the ring is simply numbered to give the lowest possible number. And you can essentially start anywhere, but you're always going to start where there is a substituent, right? Because you're always going to label that, designate that carbon number 1, at least one of them. So as an example, I have this structure here. So it has, it's a cyclohexane ring. It has bromine and a methyl group as a substituent. Now I can number this one of 2 ways. And I'm going to start with bromine. Why? Because, well, bromine comes first. So in terms of alphabetical ordering, I know bromine is going to come first, so I can give it the lowest possible number, which certainly makes sense. Now I can number the ring one of 2 ways. So I could start 1 and I could move to the top 2, 3, 4, 5. Or I could start at number 1, 2, 3. Obviously, if in that second numbering scheme, the methyl group would get the number 3 instead of the number 5. And therefore, we name this 1-bromo 3-methyl cyclohexane. And that's how you name the cycloalkane and cycloalkyl derivatives.